bonding. And it can change substantially the characteristics of these atoms or elements that are reacting with each other. Does anybody know what sodium is when it's pure? It's a metal. It's a metal that's highly explosive if it comes in contact with water. It will explode. And you know what chlorine is? It's a toxic gas that will kill you. And you went and put it all over your eggs. Was it like that when you put it on your eggs? Or whatever you put it on? No, it was now sodium chloride. It changed its properties substantially. Sodium is a solid, chlorine is a gas. When they react with each other, they form a salt. And what kind of bond is there between sodium and chloride? It's called an ionic bond. And we form these little crystalline structures in ionic bonding. You with me? So, that's ionic bonding. Now, there's another kind of bonding they talk about in the book. It's called covalent bonding. Is that like ionic bonding? Well, in a way, because it's still an attraction between the elements on our periodic table. But nobody's given up anything in this attraction. What do we do in this attraction? You share electrons. So is it going to greatly change the charge of this molecule? Are we going to form ions in covalent bonding? No, because everybody's going to kind of share electrons, and they're going to spin around everybody on the whole. Nobody's given up anything or gaining anything. So, covalent bonding is sharing of electrons. And what type of elements might share electrons? I'll give you a hint. It takes quite a bit of energy to give up or gain electrons. If I have to give up 1 or 2, that's doable. But if I have to give up 4, do you think that's going to happen? No, I'd need a huge amount of energy to do that. So the guys that are kind of hanging in the middle there, these guys tend to share or covalently bond in the chemical world. So, carbon. Carbon. That should be familiar to you somehow, carbon. Anybody ever hear of inorganic and organic chemistry? What's inorganic chemistry? If you take inorganic chemistry in school, is there going to be any carbon in your class? So if I don't have carbon in me as a molecule, that's inorganic. Is sodium chloride organic or inorganic? It's inorganic. If I have carbon in me, C6H12O6, glucose, for example, I am now called a what? I'm an organic molecule. And carbon, if you look on your periodic table, has how many valence electrons? It's got 4 valence electrons. So in order for carbon to be happy, what does it have to do? Well, it's got to gain what? It's got to gain 4 electrons. Now that's going to be difficult to do in an ionic form. But what if I share? Just kind of attract somebody to the area and share with them. How about hydrogen? Can hydrogen share as well as form an ion? Yeah, and it does it a lot with carbon. When we look at very, very large organic molecules, they tend to form very large carbon chains. And a hydrocarbon, guess what that is? What's a hydrocarbon? Any guesses? It's got hydrogen and carbon in the molecule, not water. So, the result of, example, a carbon hanging out with some hydrogens might be the sharing of electrons or electron pairs And the result of that sharing, as you can see up in this diagram, would be a molecule that we see in nature a lot. Anybody know what that's called? I'll give you a hint. The name of it's right down here. It's called methane gas. And what is its chemical formula? CH4. What's that mean? Yep, for every carbon, there's 4 hydrogens. And what are these guys doing if we look at the dot structure? Are they losing and gaining electrons? They're sharing. They're sharing electron pairs. By doing this, we make everybody happy. If I share one of the electrons with carbon, does hydrogen now have 2 electrons orbiting it? Yeah. Is it happy? Yeah. It wants 2 to be what? Stable. If we do that 4 times, all these hydrogens are happy. And is the carbon happy now? Because now it's sharing 4 more electrons with 4 hydrogen atoms. So methane, CH4, is that stable? Yeah. Is it neutral or is it charged? How come? Yep, nobody's losing, nobody's gaining. We're doing the share. Yes? So organic molecules tend to be very large because of the fact that carbon has 4 valence electrons. How did I know that? What group does carbon live in? 4. Yes? Okay. Oxygen. How many valence electrons does oxygen have? It doesn't have 4. It doesn't live in group 4. It lives in group 6. So what does oxygen want to be happy? 2 more. It tends to share also. It tends to share with itself and form oxygen molecules. But it's only going to share 2 pairs. Not all of its pairs, just 2 pairs. Yes? And it's going to share it with another oxygen. When I share more than 1 pair, if I look at the structure or the way it's drawn out, there's 2 lines between the O's. What does that mean? It means I'm sharing 2 pairs of electrons. See this guy back here? CH4. How many pairs of electrons are being shared between the carbon and the hydrogen? 1. How'd you know that? Because of the line structure. Yes? So if I'm sharing 2 pairs of electrons, I'm going to see 2 lines. Is there any that share 3? Yes! Nitrogen. Look on the chart. Nitrogen has how many valence electrons? 5. How many does it want to be stable? 8. It's got to get what? It's got to get 3 more. So nitrogen can also form molecules with itself. That's not the only thing it's going to form with, but I just want to point out the line structure. So in this case, nitrogen is sharing 3 pairs of electrons with a neighbor, and once we do that covalent bonding, everybody's going to be happy in this molecule. So when I look at, if I had a molecular spyglass and looked at nitrogen and oxygen and hydrogen in your air right now, I'd find a mixture of just these guys and a lot of the molecules of oxygen and nitrogen and hydrogen, because they tend to form molecules that covalently bond to each other and share. So I got a bunch of O's around here, but I also have a bunch of what? O2s. I have a bunch of N's around here, but I also have a bunch of N2s, and I have a bunch of H's around here, but I also have a bunch of H2s. Okay? So, covalent bonding is what larger molecules, or molecules that form from the inner guys. That's probably the best way to explain it. Ones that either want to lose or gain a small amount of electrons tend to form ionic bonds on the outers. And as we move toward the inner on this scale, they tend to form covalent or sharing.